Hello my dear students, I welcome you back to the Vidhyalakshmi NEET JEE Academy. This is Meena, chemistry teacher. Let's move to the topic. Last class we have dealt with nomenclature and preparation of aldehydes and ketones. Preparation methods of aldehyde and ketones, common method. Today we are going to see about only exclusive aldehyde preparation method and exclusively ketone preparation method. So let's first look at the preparation of aldehydes only. So these methods will be giving us only aldehydes, under which first method is Rosenman reduction. Rosenman reduction, it is a name reaction. Named reactions are very important in organic chemistry. Now first of all, Rosenman reduction, what it will do is acid halide, or you can say acid chloride or acyl chloride, any name you can use. Acyl chloride, they will convert into aldehyde. Acyl chloride, they will convert into aldehyde. See, very easy. The chlorine of acid halide replaced with hydrogen, then we got aldehyde. So now what is the reason that is doing this conversion is, we are passing hydrogen gas in the presence of palladium and barium sulfate. We are passing hydrogen gas in the presence of palladium and barium sulfate. This palladium and barium sulfate, this is known as Lindlar's catalyst. This is known as Lindlar's catalyst. So what is Rosenman reduction? Conversion of acid halide to aldehyde by passing hydrogen gas in the presence of Lindlar's catalyst. Very important, this barium sulfate over here acting as a poison. Acting as a poison. Poison sense, it is reducing the rate of, or you can say decreasing the rate of reduction. See, if you are not using barium sulfate, acid halide will convert to alcohol, which is a complete reduction. But barium sulfate is stopping the reduction at aldehyde level. So this reaction is also called as a partial, this reaction, so you can call it as a partial reduction. Partial reduction. So very important, hydrogen gas passing in presence of palladium and barium sulfate. Sometimes some books, if you refer to reference book, they will give you carbon also. So their function is same, partial reduction or stopping complete reduction. So this is what Rosenman reduction. See children, organic reactions. This sentence formation you can do on your own. Just learn the equation. What is the reactant? What is the reagent? What is the product? You just remember that and practice that, and sentence formation you can do on your own. So acid halide, when we pass hydrogen gas in the presence of Lindlar's catalyst, it gives us aldehyde. This reaction is known as Rosenman reduction. Very simple, two hydrogen are there. One hydrogen and one chlorine will make a HCl. So instead of this chlorine, what we got? Hydrogen. So this product is what? Our aldehyde. Our aldehyde. So this is Rosenman reduction, which is a first method of preparation of aldehyde. Now let's move to second method. What is the second method of preparation of aldehyde? Is Stephen reduction, or you can say Stephen reaction. This is also named reaction. Here what we will do is nitrile. Nitrile is RC triple bond N. Nitrile will be taking the stannous chloride. Stannous chloride is SnCl2, tin chloride, plus 2. Tin in plus 2 oxidation state, we call it as a stannous. We call it as a stannous. If it is a plus 4 oxidation state, we will call it as a stannic. We will call it as a stannic. So nitrile when react with stannous chloride and HCl. See, the function of this reagent is provide hydrogen. Reduction means they will be providing hydrogen. So they will provide hydrogen. What we will get is, so first what we will do, here in nitrile we have C triple bond N. What we will do, break the first pi bond, give one hydrogen to this carbon and give one hydrogen to this nitrogen. Break the pi bond, one pi bond only, give hydrogen to this carbon and one hydrogen to the nitrogen. What we will get? RCH double bond NH. This compound are known as imine. This compound is known as imine. Next, do the hydrolysis. Next, do the hydrolysis. See, hydrolysis means what? Addition of water. What we'll do is break both the bond. Break both bond, and see, water means H2O. So, sorry, you write in opposite manner. Write oxygen over here and hydrogen over here. So, what we'll do is, we'll be giving 2 hydrogen to NH and oxygen to this carbon. So, what it will become? RCHO, which is a aldehyde, plus NH3. NH3 you writing, not writing, no problem, it is a byproduct. So, this is a Stephen reaction. What is the Stephen reaction? Conversion of nitrile to aldehyde via imine. Conversion of nitrile to aldehyde via imine by treating it with stannous chloride and HCl is known as Stephen reaction. Next, we will move for next reaction. We will move to next reaction, that is DIBAH. See, if you see the Rosenman reduction, only acid halide can be converted to aldehyde. If you look at the Stephen reaction, you can convert only nitrile to aldehyde, but DIBAH is a multifunctional group. What is this? Or you can say versatile reagent. It is a versatile reagent which can convert many functional group. I will tell you what functional group it can come. Many functional groups into aldehyde. So, this is a versatile reagent. If I have amide, if I have acid halide, if I have carboxylic acid, if I have ester, all of them I want to convert into aldehyde. Then what reagent I have to use? I have to use DIBAH. Let's see what is DIBAH. So, here DIBAH represent diisobutyl aluminium hydride. Diisobutyl aluminium hydride. See, how we'll write this structure? First, we'll write the isobutyl. What is isobutyl? CH2, CH, CH3, CH3. So, this group we call it as a isobutyl group. So, this group is what? Isobutyl group. So, diisobutyl means 2 isobutyl group. Now, what is this next? Aluminium, then hydrogen. So, diisobutyl aluminium hydride. In question paper, sometimes they will give you like this also. IBU 2 times aluminium hydride. Same thing only. It means also what? Diisobutyl aluminium hydride. Now, what is the function of this reagent? It will convert many functional group into aldehyde. Many functional group means here it will convert. See, if I am taking nitrile, if I am taking nitrile R C triple bond N, and I am taking acid halide, then I am taking carboxylic acid and I am taking ester. So, this all functional group, if I am treating with DIBAH followed by hydrolysis, directly what is the product? Product is aldehyde. Very, very easy and important. DIBAH is a versatile reagent which convert many functional group like nitrile, acid halide, carboxylic acid, ester into aldehyde. So, very, very important. This can be come in like in board exam, they can ask you write about DIBAH, 1 mark question, or sometimes in exam they will give you the reaction, they will give you arrow mark and reagent, and they will ask you to write the product. So, if you are seeing in arrow mark DIBAH followed by hydrolysis, immediately what you have to write? You have to write aldehyde as a product. Next one is from oxidation of, by oxidation of methyl benzene. Methyl benzene is known as toluene also. Methyl benzene is known as toluene. Now, from methyl benzene, under methyl benzene also we have three methods. Okay. So, first one is oxidation of methyl benzene, under that Etard reaction. Now, this is also very important named reaction. Etard reaction is very important named reaction. What is Etard reaction? I am taking toluene, which is also known as methyl benzene. So, I will write toluene in this manner. According to our convenient, we can write this structure. So, toluene, benzene ring, CH3 toluene. And when I treat the toluene with chromyl chloride, see chromyl chloride formula is CrO2Cl2. CrO2Cl2. So, this how I am writing OCrOCl2. So, I am writing this reagent according to my convenience. OCrOCl2. In the presence of CS2, in the presence of carbon disulfide as a solvent, what I will do is, see, very simple. Here this hydrogen give to this oxygen and this oxygen attached to this carbon. What it will become? Intermediate complex is very important over here. Carbon I attach with oxygen and Cr, and this hydrogen I attach to this oxygen, so OHCl2. Same manner, one more molecule of OCrOCl2, that is the chromyl chloride, CrO2Cl2 if I take, same thing I can do with this hydrogen also. So, one more mole of OCrOCl2 I am taking. I am doing this oxygen I am attaching with this carbon and this hydrogen I am giving to this oxygen. So, what it will become one more? OCrOHCl2, and here first hydrogen is acetic. This is what? Chromium complex. This is chromium complex, and here this intermediate is also very important, chromium complex. So, toluene, or which is also known as methyl benzene, react with chromyl chloride, chromyl chloride. What it gives? It gives the intermediate complex which is known as chromium complex, Now, this chromium complex on hydrolysis means what? Addition of water. See, water contain H plus and OH minus. So, how I am breaking bond is, see this electron I am shifting to here, so it will become C double bond O, and this electron I am giving to this oxygen. See, when chromium lose its bonded electron, it will get positive charge. So, chromium positive. Why? The bond between oxygen and chromium, these electrons I completely shifted over here. So, chromium lost its shared pair of electrons. So, it got positive charge. Now, between this carbon and oxygen, this both electron I am shifting towards the oxygen. So, this oxygen will get negative charge. Very simple. From water, you are having, water have positive H plus and OH minus. Now, tell me children, negative will take positive, positive will take negative, very simple. So, this O minus will go with this H plus will go with this, this H plus will go with this O minus, and this OH minus will go with, chromium plus, and this H plus will go with O minus. So, what is the product form? Again I will be writing, yes. So, here OH minus and you have H plus from the water. So, OH minus will go with chromium plus and H plus will go with O minus. So, what is the product? Here our main product is benzene ring and carbon, here hydrogen. Now, see C double bond O. So, I have shifted now. What is this? Benzaldehyde. This is benzaldehyde. Plus what is the byproduct? See, look at here, chromium you have, here OH you have, O minus and H plus from water OH, then one more OH you have Cl2, right? Correct? So, here also same, chromium plus OH, so chromium OH, this right side OH Cl2, same thing. So, same thing shall I write like this, 2 moles of chromium OH twice Cl2. So, this is a byproduct, you are writing, not a matter. So, just do the hydrolysis here, and this bond you shifted over here, then what you will get? You will get the benzaldehyde as a product. Very important. What is Etard reaction? Many times in NEET, JEE as well as CBSE board, they are asking this question. Very important. How they will ask you? A plus this reagent gives B, B on hydrolysis will give you C. So they will give you in the form of sequential, so A, B and C. So what are ABC? Find the ABC. Like that also they will ask you. So what is Etard reaction? When toluene react with chromyl chloride in the presence of carbon disulfide gives chromium complex, which on hydrolysis gives benzaldehyde, is known as Etard reaction. I hope it's clear. Let's move to next equation. Actually next also similar to Etard but not Etard. See, next we are going to deal same from by using toluene. If we are using chromyl chloride and we are getting the benzaldehyde, that reaction is known as Etard reaction. But if we are using chromium oxide, if we are using chromium oxide and acetic anhydride, chromium oxide and acetic anhydride, then also product will be same, that benzaldehyde will get, but that reaction, this reaction is not called as a Etard, remember. So what we are, same manner we are going to do, I am going to write toluene, and I am going to treat with acetic anhydride. What is the formula of acetic anhydride? CH3, C double bond O, O, C double bond O, CH3. This is what? Acetic anhydride. In the presence of chromium oxide, CrO3. So then what we will get? Same manner here we will get the intermediate. We will get intermediate. Look at here, same manner. What I am going to do? I am going to break this bond homolytically. Homolytical bond fission will give you free radical. So here C dot O dot. Same manner this carbon and hydrogen bond also I am going to break. So what you will get? C dot and H dot. So now see, this H dot will go with this C dot and will remove in the form of byproduct. So what will remove? CH3, C double bond O, this C dot and H dot will make a bond and it will remove in the form of aldehyde. Byproduct also aldehyde, see, CH3, C double bond O, H as a byproduct. Now, then what is remaining? This C dot and this O dot will join with this C dot. Now what you will get? CH, here OCO, CH3. Clear? This O dot and C dot form bond OCO, CH3 attached with here, and byproduct this H dot will join with this C dot and form CH3, C double bond OH, which is removed in the form of byproduct. Same thing we can do with second hydrogen also. If I am taking second molecule, so simply I am writing 2 over here. So with second hydrogen also same COCO, CH3. This is a complex. This is a benzylidene diacetate. This complex is known as benzylidene diacetate. Benzylidene diacetate. Now, which on hydrolysis? Again same thing. Hydrolysis means what? Water. And like previously you do same thing here. This bonded electron I am shifting over here. This I am shifting over here. So what you are going to get is, you are going to get benzaldehyde. Now what is the byproduct? Here if you remove here carbon plus, this oxygen minus, and from water you have H plus and OH minus. OH minus will attack this C plus, H plus will attack on this O minus. Then what you will get? Plus OH, C double bond O, CH3, 2 molecules. I can write 2 molecules of C double bond O, CH3, C double bond O. How? CH3, this CH3, this CH3, this CH3, CO, O minus this H plus, so OH, OH. So same manner, here see, CH3, C double bond O and carbon is having plus charge. So from water OH minus it will accept and it will form the OH. So byproduct is what? Acetic acid, CH3, C double bond O, OH. Here byproduct what we got? We got acetaldehyde. So this is what? It is not Etard reaction, but it is similar to Etard reaction. What is this reaction? Toluene when treated with acetic anhydride and chromium oxide, it gives one complex which is known as benzylidene diacetate, which on hydrolysis give benzaldehyde. Okay. Next we will move to next reaction, that is very important, toluene. Now here if I am writing Cl2 in the presence of H mu, that means free radical substitution reaction. From alkane, hydrogen will be substituted with chlorine. Very, very important. If I am writing same toluene and I am writing chlorine in the presence of AlCl3, it means electrophilic substitution. Don't get confused, and in competitive exam here only will make mistakes. So here electrophilic substitution means you will get orthochlorotoluene and parachlorotoluene. You will get parachlorotoluene, but this is not our present topic. So just for your information only I have given you. If you are same thing, reactant is same, reagent chlorine same, only see here if you are seeing AlCl3 different product you will get. But if you are seeing sunlight, this H mu means what? Sunlight, then you will get the different product. Please be very, very careful. So when you are seeing sunlight, this means what? Free radical substitution, and it will not occur in benzene ring, it will occur in side chain, alkane part. But here electrophilic substitution will occur on benzene ring. Very important. Free radical substitution will occur at side chain, but electrophilic substitution will occur in benzene ring. So here what will happen if I am taking 2 moles of Cl2, 2 hydrogen will replace with 2 chlorine. So what I will get? Cl and hydrogen. Now next what I am going to do? I am going to do hydrolysis. Hydrolysis means what? You can take either water or you can take aqueous NaOH also. What we are going to do over here is nucleophilic substitution. See, what is the nucleophile over this? Chlorine or what? Nucleophile. See, the chlorine will substitute with OH group. So either you can take water or you can take aqueous NaOH also. Both are correct. NCERT if you see they are giving water. No problem. You can take any one of these reaction. So what we are going to do? This 2 chlorine will substitute or replace with OH group. Now, always remember children, whenever 2 OH group are present at same carbon, 2 OH group present at same carbon, that compound is highly unstable and immediately removal of water molecules will take place. So what we are going to do? We are going to remove water from here. Minus water. So what you will get? Benzene ring, and you are having CHO, benzaldehyde. So side chain chlorination of toluene followed by hydrolysis, and that time what? We are going to remove the water, then we got benzaldehyde. This is also very, very important. Remember the difference. If you are seeing in arrow mark chlorine in AlCl3, it means electrophilic substitution. You will get orthochlorotoluene. But if you are seeing the H mu, which means sunlight, then you have to do side chain chlorination, or it is what? Which mechanism? Free radical substitution. Then we got the both 2 hydrogen we replaced with chlorine. We got this compound benzyl chloride. This compound is known as benzyl chloride. Okay, benzyl chloride, intermediate compound. Then for which on nucleophilic substitution reaction we got this, and followed by removal of water we got the benzaldehyde. Very, very important. Next, last method of aldehyde preparation is there, which is important name reaction, Gattermann-Koch reaction. Which is a Gattermann-Koch reaction. Pause the video and write the notes, children. Now next part is Gattermann-Koch reaction. This is name reaction and important. See, Gattermann reactions you have seen in haloalkane, haloarine as well as in amines chapter. What is Gattermann reaction? Gattermann reaction is preparation of chlorobenzene and preparation of bromobenzene. But Gattermann-Koch reaction is preparation of benzaldehyde. Remember the difference. If there is no Koch, the product is different, chlorobenzene and bromobenzene. But when Koch is added, the product is different. See, remember, very, very careful. Gattermann is different, Gattermann-Koch is different. So Gattermann-Koch reaction is actually preparation of benzaldehyde from benzene by treating it with CO plus HCl. What is this? Carbon monoxide and HCl in the presence of catalysts like AlCl3 or CuCl. Copper chloride also you can take, or you can take AlCl3. So actually what is this reaction? Let's see. Benzene treated with carbon monoxide and HCl to give benzaldehyde in the presence of AlCl3 catalyst is known as Gattermann-Koch reaction. Am I clear? Preparation of benzaldehyde from benzene by treating it with carbon monoxide and HCl in the presence of AlCl3 as a catalyst is known as Gattermann-Koch reaction. Now what is happening over here is, actually this is an example of formylation reaction. You might have heard about alkylation, acylation reaction. Same like acylation, it is known as formylation reaction. It is what? Formylation reaction. What is the formal? See, if you are taking R, C double bond O. C double bond O, R group is known as acyl. So instead of R, if you are having H, this group is known as formyl group. C double bond O H, this group is known as formyl, and this is an electrophile in this reaction. How it is electrophile? Let's look at here. C triple bond O, here minus, here plus. So initially when HCl will attack H plus and Cl minus, H plus will attack on carbon. So what you will get? H triple bond O plus. Now next step what will happen? Cl minus will be there. So these electrons I am shifting towards the oxygen. Why I am shifting? Because positive charge on oxygen is not stable. Oxygen is highly electronegative atom. So what will happen here? Carbon valency is 4. If you are shifting the electron, now carbon lost its valency, or you can say carbon will get partial positive charge. So in order to satisfy this chlorine will attack on the carbon. When you are shifting these electrons to the oxygen, carbon will get positive charge, but this chlorine will come and say Cl minus will attack on carbon, so positive negative will form a bond. So what will happen? Carbon, here double bond O, here you have chlorine, here you have hydrogen. What is this group? This is known as formyl chloride. Like acyl chloride, like that you have formyl chloride. Now next what will happen? This formyl chloride, when it react with AlCl3, this chlorine will take both the electrons and move in with AlCl3, then you will get AlCl4 minus plus HC double bond O plus. Now this is what? Electrophile over here. Now you know very well electrophilic substitution reaction. This electrophile will attack on benzene ring and you will get the benzaldehyde. So next one is what? This electrophile I am writing over here. So I am having benzene ring. Here what is this electrophile? HC double bond O plus. So from benzene ring hydrogen is there, H plus will replace with this group. So what you will get? C double bond O H. So this will attack over here and this hydrogen will take. Okay. So this is actually Gattermann-Koch reaction. You don't need mechanism, but you have to remember that when benzene treated with carbon monoxide and HCl, finally what is this formylation reaction? We are getting formyl group by this combination. CO plus HCl is finally giving what ma? Formyl chloride, and after that, like normal reaction, what you are doing in acylation, chlorine will be removed and remaining part will act as an electrophile, and H plus from the benzene ring will replace by this electrophile. This is about the Gattermann-Koch reaction. So these are what? Preparation of aldehydes. So quickly recollect all the methods. First method we done with, what is that first method? Rosenman reduction, acyl halide to aldehyde. Second method is Stephen reaction. Third is DIBAH. Fourth one is Etard reaction. Fifth one is similar to Etard but not Etard. Then sixth one is side chain chlorination, and seventh one is Gattermann-Koch reaction. Although here heading is 6, but total how many methods we have studied? Total 7 methods of preparation of only aldehydes. Now we will move for the preparations of only ketones. We will move for preparation of only ketones. So under which first method is, we have only 3 methods for the preparation of only ketones. First method is from acyl chloride. Again you know what is acyl chloride? R C double bond O Cl, acyl chloride. If you treat with dialkyl cadmium, R2CD, or same thing I can write as a cadmium valency is what ma? 2. So what we can write? R one side, another R other side. Okay, dialkyl cadmium. When acyl chloride treated with dialkyl cadmium, what we are going to do? Very simple. This Cl group we are going to replace with R group, simple. The Cl group we are going to replace with R group. So what we will get? R, C double bond O, R. Now you have one more R also. So what I am going to do? I am going to take 2 moles. Here if I am taking 2 moles, here also we will get 2 moles. Now these 2 chlorine atoms will go with cadmium dichloride. So very easy. Suppose for example I am taking here CH3, C double bond O, let it be chlorine plus here I am taking C2H5 twice cadmium. So what is the product? What is the product over here? See, same thing, this chlorine, what is the R group? You separate this C2H5 twice means what? One side of cadmium C2H5, another side also C2H5. So this chlorine will be replaced with alkyl group. What is alkyl group here? Ethyl C2H5. So what I am going to, our product is going to be CH3 C double bond O C2H5. Now same thing here, I am taking 2 moles, here also I will get 2 moles. Now 2 chlorine will attach with cadmium. So cadmium dichloride. Okay, this is from the acyl chloride. Reaction of acyl chloride with the dialkyl cadmium, what we are getting? We are getting ketone. So next we will move for the next reaction. Next is from nitriles. What is the nitriles? Cyanides. Reaction of nitriles, see, RC triple bond N. Nitrile react with Grignard reagent. I am taking any Grignard reagent, methyl magnesium bromide. Any Grignard reagent you can take. What is Grignard reagent? Alkyl magnesium halide is known as Grignard reagent. And you know very well, Grignard reagent is very, very versatile reagent. It is used in almost every chapter of the organic. And this R group of the Grignard reagent is nucleophile. Why? Because this magnesium is a metal, partially positive, and this alkyl group as a carbon is a non-metal, so we will get partially negative. And this is a like a strong nucleophile. It can act as a nucleophile. Now look at over here. If I shift these electrons to this nitrogen, what will happen? Nitrogen will get negative charge, carbon will get positive charge. Now this R group, which is a methyl over here, where it will attack? Tell me. This is a negative, means obviously it will attack as positive. Nucleophile will attack an electrophilic center. What is the electrophilic center over here? Carbon is the electrophilic center. So what it is going to happen is, this methyl group is going to attack on carbon. So what you will get? You will get R, C, methyl. Now one bond we broke, see, 2 more bond remain, N. Now N minus. Now this MgBr will attach over here because this is a positively charged. It will attach with minus. Now you do the hydrolysis. What we are going to do with hydrolysis is, just look at over here. Hydrolysis means what? Oxygen and so oxygen, here hydrogen, here hydrogen. So break both the bond and give oxygen to the carbon and hydrogen to this nitrogen. Byproduct you don't need to write. So what is our product over here is RCCH3 double bond O, which is a ketone. Am I clear? See, both the bond we broke and oxygen, see, when we breaking bond we have to make bond also. Now carbon need to make 2 bonds, so it will make double bond with oxygen. This hydrogen will go with this nitrogen, we don't need to write the byproduct. So this is our product, which is a ketone. So when nitrile treat with Grignard reagent followed by hydrolysis, we are getting the ketone. So this is second method. Now one more method is their last method, that is what? Acylation of benzene. You can do acylation of benzene. Like previously we have done similar, but previously we took formyl chloride, here we will take the acyl chloride. So here from benzene ring or substituted benzene. See, I am taking benzene ring. So I am treating with acid chloride or acyl chloride in the presence of AlCl3 as a catalyst. What will happen? You know, this Cl will go here. This is a electrophile. The H plus from benzene ring will replace with this electrophile. So then what will get? It will be C double bond O R. So what is this? Ketone. This is a ketone. So here this is an example of electrophilic substitution reaction. Under electrophilic substitution reaction also what reaction? Friedel-Crafts, this reaction is Friedel-Crafts acylation. Why we are calling acylation? C double bond O, R group is attached with benzene ring and one of the hydrogen from benzene ring is replaced with acyl group. So, we are calling it as a acylation. We are adding acyl group to benzene ring. So, these are the preparation methods of ketones. Quickly revise what are the preparation methods of ketones. First method we saw first method is from acyl chloride. Acyl chloride when treated with dialkyl cadmium we got ketone. Second method is from nitrile and third method is from Friedel-Crafts acylation of benzene where we are doing the electrophilic substitution reaction. So, these are the preparation methods of aldehydes and ketones. So, quickly revise common method only aldehydes and only ketones, and among all these only aldehydes, preparation methods of only aldehydes involve maximum number of named reactions, and named reactions are very important. Practice and write and apply to the questions. So, directly questions will come from named reaction or indirectly also questions will come in the form of conversion or in the form of sequence question. Okay. Give name of the reagents, names of the reagent to bring about the following transformation. It is like almost conversion question also. In exam, another way also they can ask you, convert, how do you convert hexane 1-ol to hexanol? So, they will give you same thing in the form of conversion, or they are asking reagent. Don't write answer as a answer is PCC like that. Don't write. Nobody will give you the mark in CBSE. What you have to do in such question is how to approach this kind of question. First, always write the structure of reactant and structure of product and then think the reagent and write the reagent in arrow mark. So, that is the correct way to answer this kind of question. So, don't simply write the answer reagent. You have to write the reactant. You have to put the arrow mark, you have to write the product, and above arrow mark or below arrow mark you write the reagent, then you will get the full mark. So, what is this hexane 1-ol? Already as last video also I have taught you how to convert this name into structure. Always you first catch on root word. When you are converting name into structure, always focus on word root. What is the word root? Hex. Hex means how many carbon? 6 carbon. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Hex means 6 carbon. Next you focus on primary suffix. What is primary suffix over here? N. N means what? All carbon-carbon bond are single bond. So, all carbon-carbon bond are single bond. Next you focus here OL. What position OL? What is the OL? OL is alcohol. So, here alcohol means OH group. So, this is our reactant. Remaining valency you can satisfy with hydrogen. Now, 2, I am writing arrow mark. 2, next hexanol. What is the hex? Again same 6 carbon. 1, 2, 3, 4, 5, 6. Now, look at over here Al. Al is for what? Aldehyde functional group. So, aldehyde functional group what? C double bond OH. So, you are converting, this is what? Primary alcohol. Primary alcohol. See, remaining valency of carbon, please write with hydrogen. Remaining valency of carbon will be satisfied with hydrogen. So, this is primary alcohol, this is what? Aldehyde. Tell me what are the reagents which will convert primary alcohol to aldehyde? Pause the video and write the answer. So, mild oxidizing agent like PCC, PDC will convert primary alcohol to aldehyde. So, what is the reagent over here? Pyridinium chlorochromate. What is the PCC? Pyridinium chlorochromate. Pyridinium chlorochromate. Okay. Let us move to the second question. Cyclohexanol to cyclohexanone. Cyclo means cyclic ring structure. Hexanone means how many carbon? Hex means 6 carbon. So, ring structure with 6 carbon and you are having OL. OL means alcohol. They are not mentioning position, means that position will be taking as a 1. Position number 1, whether you are mentioning or not mentioning, same thing. 1. Now, cyclohexanone. Cyclohexanone is what? One will use for ketone. One will use for ketone. That means this. That means what? Secondary alcohol. This is what? Secondary alcohol. This is secondary carbon. Secondary alcohol, we are converting it to ketone. So what reagent will convert? Which reagents will convert secondary alcohol to ketone? You can use strong oxidizing agent like potassium dichromate, potassium permanganate and Jones reagent, or you can use mild oxidizing reagent like PCC, PDC and CrO3 plus CH2Cl2. So any one of these reagent you can use to convert secondary alcohol to ketone. So I am using over here KMnO4. Okay, you can write any reagent, KMnO4 in acidic medium, or you can write PCC also, answer will be correct. Okay. So let's move to the next question. Parafluorotoluene. So when you are this parafluoro is substitutes, I told you in last lecture, always substituents try to write later. First you have to focus from center to end. That is what toluene over here. So what is the toluene? Toluene structure is benzene ring and CH. This is our toluene. And now what is this parafluoro? Para means what? Opposite position. Opposite position of the CH3 is para position. Which group? Fluorine. So this is what? Parafluorotoluene. 2. Put a arrow mark. What is this? Parafluorobenzaldehyde. That means benzaldehyde is what? Benzene ring and CHO, and para position you have fluoro. That means from here to here, just observe what is the change happening. Fluorine, same thing. Nothing changed. So that means CH3 group is changes to CHO. You have just before we have studied two methods which will convert CH3 into CHO. One is Etard reaction. Another one is like similar to Etard reaction by using the chromic oxide and acetic anhydride. So any one reagent you can write. I am writing Etard reaction. What is the reagent in Etard reaction? Chromyl chloride in the presence of CH2 followed by hydrolysis. Or you can write chromic oxide in the presence of acetic anhydride also you can write, followed by hydrolysis. All those reagents should be correct. Now let's move to the next question. Ethane nitrile to ethanol. What is ethane nitrile? CH3 C triple bond N. What is the ethanol? Ethanol means 2 carbon and Al means aldehyde. See, eth means 2 carbon, N means single bond, carbon bond is single bond. Then Al means aldehyde, and they are not mentioning position, means first position we have the functional group. So it is what? Ethanol. So remaining valency of carbon, please satisfied with hydrogen. Now what is this method? Stephen reaction. Or you can use dibyl H also. You can use dibyl H followed by hydrolysis. You can use Stephen reagent also. What are those reagents? SnCl2 plus HCl followed by hydrolysis. Or what you can write? Or dibyl H followed by hydrolysis. So any one of these reagents can convert nitrile to aldehyde, or you can say ethane nitrile to ethanol. Okay, please note down this. Now let's move to the next question. Next question, write the product of this equation. See, this question is already repeated in CBSE and very easy. Already we have covered in preparation method. Just you have to identify this equation comes under which method, where you have studied. See over here, what is this? Acid halide. This is acid halide and this is benzene. Or you can say acyl halide. This is what? Friedel-Crafts acylation of benzene. So what we did? This chlorine we have removed, here plus charge, and it will attack on the, this will attack on the benzene ring. What we will get? Our product will be C double bond O C2H5. So what is the common name? Common name and IUPAC name. Let's write the IUPAC name. C2H5, shall I write it as a CH2 CH3. So what is this? 1 carbon, second, third. 1 carbon you have substituents, benzene substituents known as phenyl, 1 phenyl, 3 carbon means prop, single bond N, and first position you have ketone. So 1 phenyl propane 1 on. They can give you 1 phenyl propane 1 on. Why I wrote 1 phenyl? Already in last lecture I have explained this. This is a open chain and this is a cyclic system, and open chain is having functional group. So open chain will take as a parent chain or main chain, and this will be automatically become as a substitutes. And when benzene becomes substitutes, what we will write? We will write as a phenol. Clear? What is this reaction? This is also preparation of ketone only. What is this? Acyl chloride, and this is dialkyl cadmium. See this reaction, shall I write it as a C6H5 CH2 cadmium CH2 C6H5, same only 2 times. So I am writing left side and right side, and plus 2 times of CH3 C double bond O Cl. So what we did, this chlorine we replace with this alkyl group, that's it now. Chlorine replaced with this alkyl group, and remember, where here we are breaking bond here over here, right? When you are making bond also, from same carbon you have to make. You cannot write C6. Here benzene ring you cannot attach. What you have to attach? CS2. Why? Because this carbon is attached to cadmium. There we are breaking bond over there. So this carbon is making bond over here also. So here 2 CH3 C double bond. So instead of this chlorine, what you are going to attach? This group CH2 C6H5 plus cadmium chloride will be your product. Very, very easy. All equations are very easy. Clear? Noted? Next, move to the next question. What is this method? Before lecture we have done this question. Pause the video and try to answer this. This is what? Alkyne. And what is this? Hg plus 2 H2SO4. What is this? This is the hydration of alkyne. Hydration of alkyne. What we did there? We add the water. We added water according to Markovnikov rule, and then we did tautomerism. So same thing you have to do over here. I am writing CH3 C triple bond CH, addition of water. See, water means what? H plus OH minus. How we will add? We will add according to Markovnikov rule. According to H2SO4 plus, we can write H plus also, no problem. We will add the water according to Markovnikov rule. Break the pi bond, break the 1 pi bond, add HOH according to Markovnikov rule. What is Markovnikov rule? Negative part. What is negative part over here? OH minus. Negative part will add it to that carbon which contain less number of hydrogen. So out of these two, which contain less number? This carbon do not contain any hydrogen. This carbon contain 1 hydrogen. So less number means what? Here 0, here 1. 0. So the OH will get attached to this carbon and H will get attached to this carbon. So what we will get? CH3 COH double bond CH. And one more H attached from that water, CH2. Now do the tautomerism. What is tautomerism? Give number 1 to the oxygen. Told you. This double bond you shifted over here, you shift this hydrogen to this carbon. So the double bond between these two carbon, I have shifted over carbon and oxygen. Then hydrogen of oxygens will shift it to the carbon. So what it will become? CH3 single bond C double bond O. Why I wrote double bond? Because from here we have shifted double bond to here. Next, single bond CH2 and this hydrogen. So what it will become? CH3, which is a acetone. Common name of this ketone is acetone. Okay. So this is the hydration followed by tautomerism. This process is known as what? Tautomerism. So what we are doing? Shifting of double bond and hydrogen. We are shifting double bond as well as hydrogen. Next we will move to next topic. We will go for physical properties. Okay. What is physical? See, basically from physical properties you will get two kind of question. One is based on solubility, another one is based on boiling point. So first we will see boiling point. For any organic chapter, any chapter of organic, same concept you can apply in order to answer the boiling point related questions. So what is this? Boiling point is directly proportional to molar mass. First of all, remember, boiling point directly proportional to molar mass. Now, if I am having, for example, why it is so? Because molar mass directly proportional to van der Waals force of attraction. Molar mass directly proportional to van der Waals force of attraction. Now, if I am taking same family means I can take aldehyde family, I can take ketone, I can take alcohol, I can take amines, whatever, same family, within same family. What we are going to check? We are going to check the molar mass. Molar mass means number of carbon. As the number of carbon atom increases, boiling point increases. For example, I am taking aldehyde, CHO, first member of aldehyde, then second member of aldehyde, CH3, CHO. Then CH3, CH2, CHO. That means as the molar mass increases, boiling point increases. So this is what boiling point order. This is boiling point order. As the number of carbon increases, molecular mass increases and van der Waals force of attraction increases. As a result, boiling point increases. Same manner alcohol I can write. See, this physical properties not only belongs to this chapter. Every chapter of organic physical properties you can answer if you listen to this class carefully. So if I am taking alcohol, CH3OH, C2H5OH and C3H7OH. So if I take alcohol, what will happen here? More carbon, more molar mass, so boiling point increases. So within the same family, as the number of carbon increases, molar mass increases and van der Waals force of attraction increases, then boiling point increases. Now, next, if I am having different family, different family of comparable molar mass, different family of comparable molar mass. If I am having different family of comparable molar mass, many times the questions are coming from this. So you might have seen in previous year question bank, why ethanol is having more boiling point than methoxymethane? Why amines are having more boiling point than ether? Why alcohol are having more boiling point than hydrocarbon? And etc, etc, etc. So here reason over here is boiling point is directly proportional to force of attraction. Force of attraction. Now in force of attraction, mostly we will check hydrogen bonding more. Then van der Waals force of attraction. In a van der Waals also you will check dipole force of attraction more. Then you will check London forces. London force means which present in non-polar molecule, very weakest force of attraction. Okay, hydrogen bonding, dipole interaction and London forces. In hydrogen, within hydrogen bonding also, alcohol hydrogen bonding will be strong than amines. Again you have to check. So finally what you have to check is, you have to check the force of attraction. If any molecule is having strong force of attraction, that molecule boiling point will be more. That concept you have to catch. So force of attraction increases, boiling point increases. Now I will give you the example here. Please note down this. I am giving you propanol. Otherwise I will give you directly first order. Alcohol. If you see here, carboxylic acid will be having highest boiling point due to extensive hydrogen bonding. Then you will be having alcohol. Then you will have amines. Then you will have ketone. Then you will have aldehyde. Then you have ether. Then you have hydrocarbon, which is a alkane. Then you have a alkane. Very important. Please remember this order. Many times they are asking. This carboxylic acid, alcohol and amines, they are having hydrogen bonding. Ketone, aldehyde and ether are having dipole interaction. And this alkane are having very weak force, that is London force of attraction. Very important. And now why alcohol are having more boiling point than amines? So they will ask you the question, C2H5OH is having more boiling point than C2H5NH2. Why? Because hydrogen bonding in alcohol, both are having hydrogen bonding. But strength of hydrogen bonding is strong in alcohol due to the more electronegativity of oxygen than amines. So electronegativity of oxygen is more than nitrogen. Both are forming the hydrogen bonding, but the extent of hydrogen bonding is strong in alcohol. Because of that, alcohol is having more boiling point than amines. So theory questions they are asking for 1 mark, very easily you can answer. If I ask you why ethanol is having more boiling point, this is boiling point order, why it is having more boiling point then acetaldehyde. Same thing now you can say, alcohol is having strong boiling point alcohol is having strong boiling point compared to, here we can write propanol, here 2 carbon 1 oxygen, here also, okay fine. Here it is having strong force of attraction due to intermolecular hydrogen bonding, but it is having weak force of attraction because of dipole-dipole interaction. Like any questions, generally if you understand one concept, boiling, more force of attraction means more boiling point, less force of attraction means less boiling point. Suppose in exam if you do not remember which kind of force exists, at least you write that compound which is having more boiling point is having more force of attraction. If you write that, at least half mark they will give, but try to write the exact point. Okay, let's see the comparison. If I am taking, so we will solve the questions based on boiling point, then we will go for the solubility. Okay, note down. Arrange the following compounds in the increasing order of boiling points. What is this? This is a aldehyde. I am giving A, and this is what? This is alcohol, I am giving B, and this is what? Ether, I am putting here C. This is what? Hydrocarbon or alkane, you can say this is a D. Now easily you can say, pause the video and try to answer. Alcohol B, then you have aldehyde A, then you have ether, then you have alkane. Very easy, this is the order of boiling point. Sorry, this is decreasing order, okay, they are asking you increasing order. Increasing order means D, C, A, B. This is the increasing order of boiling point. This is the increasing order of boiling point. Okay. So very easily you remember the order: carboxylic acid, alcohol, amines. Then you have ketone, aldehyde, and ether, and then alkane. And though these compounds will be having comparable molar mass. Comparable means almost same. Just 1 or 2 difference will be there, but almost they should have approximately same molar mass. Then this order will be. Thank you so much. Next class we will be continuing with chemical properties of aldehyde and ketones. In one lecture we will try to finish the chemical properties, then we will look for the carboxylic acid, then we will go for the biomolecules. So after finishing carboxylic acid we will solve the previous year questions. In one lecture we will fully solve the previous year question, then we will go for the next chapter. All the best, study well, bye bye, see you in next class.